once again, everybody. My name is Angelo Garcia. You've probably heard the phrase, girls go to college to get more knowledge. Now, do you remember the second part of that phrase? If you said boys go to Jupiter to get completely destroyed by acid rain and terrifying thunderstorms, you would be factually correct. That's right. Space is terrifying and extreme, but it's beautiful in so many ways. When I took astronomy last semester, it opened my eyes to the beauties and terrors and the fascinating aspects of space and our universe. I believe that astronomy and astrophysics and anything to do with the universe is the most beautiful of the sciences, and in some ways, one of the most beautiful arts. And I would love to share that beauty with you tonight. Now, there are so many aspects about space that I just really wish that I could share with you in this short video. But right now, let's start with what we're familiar with. The planets. Now, a planet is a large object which surrounds the sun, not necessarily a sun, but any star in its field of gravity. Now, every planet is different in its own respect. Some are solid, some are gaseous, some have atmospheres, some are mostly covered in water. Let's compare Mercury and Venus, the two planets that are closest to our sun. Mercury is rather small for a planet, and it has no atmosphere whatsoever. Likewise, Venus is a planet that is close in size to our Earth, yet its atmosphere is close to 90 times stronger than our atmosphere at sea level. Now, I believe that's quite an interesting contrast between the two planets that are virtually right next to each other. Now, one planet that I find quite interesting is Mars. And I think the reason why a lot of astronomers find Mars fascinating is because it is the only planet that we can realistically explore. Its gravity isn't too strong, its atmosphere isn't too extreme, and it's not too far away from Earth. Now, one thing that a lot of planets have in common is a gravity field. Now, not a gravity field, an electromagnetic field. Now, the magnetic field of Earth comes from all of the moving metals in the molten core of Earth. And this magnetic field is what protects us from the extreme solar radiation that comes from the sun. If it weren't for this magnetic field, we wouldn't be able to live on this planet. Unfortunately for Mars, the core of Mars is mostly rock, very little metal, which means that Mars has a very weak, if any, magnetic field at all. Now, that would actually prove to be the biggest challenge for humans to inhabit Mars. It wouldn't be the water source or the oxygen source. It would be the extreme levels of radiation that are coming from the sun. If we were to build a habitat on Mars, we would have to accommodate for those extreme levels of radiation. Now, if you look at a picture of Mars, you'll see that the northern half of Mars is very smooth. It almost looks like the bed of an ocean. A lot of scientists speculate that Mars was actually covered in water, very similar to Earth. But because of its lack of a magnetic field protecting it from the radiation, all of that water vaporized and eventually dissipated into space, which is why Mars is virtually a desert in its own respect. Let's go even farther into space, and let's go to the jovial planets, also known as the gaseous planets, such as Jupiter, Neptune, Uranus, and Saturn. Jupiter is a planet that I find particularly interesting due to its immense storms and its chemical composure across the entire planet. Now, even though it is hardly solid at all, it still constitutes as a planet because it is a large mass which still orbits the sun. The storms on Jupiter, as it is a gaseous planet, have no comparison almost to the storms on Earth. You may be familiar with a great red dot on Jupiter, known as the Great Red Spot, very respectful name. It is a hurricane to say the least, on Jupiter, which is actually 3 times longer in diameter than, than the Earth's diameter. Now, to fathom a storm of that size is incredible, to be quite honest with you. There is so much more about the planets that I wish I could explain to you, but in the interest of time, let's move on to other celestial bodies that are less familiar to us, namely black holes. Now, the, inf- the infamous black hole is something that has puzzled scientists for decades. It is only recently when we have acquired a legitimate photograph of a black hole, which not only confirms its existence, but it also confirms its physics. You can see the light bending around the black hole coming from behind as if there were a light source behind it. Now, that is technically true. There is a light source behind the black hole. But, as the picture may suggest, it is not larger than the black hole itself. It is actually a series of stars and celestial matter whose light is bending around the black hole due to the black hole's physical and chemical attributes. Now, because a black hole sucks in light due to its immense gravity, we cannot observe a black hole through a telescope which absorbs radiation, such as light or gamma radiation. But we can observe the black hole's effect on its nature, which is the primary way which scientists observe black holes. And one very, very interesting scientific fact which scientists have discovered about black holes is that the larger a black hole is, the weaker its its the weaker its event horizon is compared to that of smaller black holes. If you were to send a spaceship to a black hole whose diameter is about 20 miles wide, the spaceship would simply fall apart, to say the very least. But if you were to send a spaceship to a supermassive black hole, such as the one at the very center of our galaxy, it may be possible for the spaceship to enter the black hole and observe what is inside. Of course, the hard part of getting the spaceship to the black hole is having it travel the roughly 50,000 years, light years, in fact, to reach the black hole. Unfortunately, highly doubt that will be able to happen in our lifetime. Now, let's move on to something a little bit more influential in our universe, and that is stars. Stars, when you think about it, are responsible for everything in our known universe. Now, a star is born typically by the collection of hydrogen atoms in the universe. Hydrogen atoms usually collide and they group together in a very, very, very slow process until they all become one large mass which has immense pressure at the very center of that mass. Now, after billions of years, perhaps maybe millions of years, the pressure inside of that mass will become so great that the atoms themselves will actually fuse together to create helium. Now, the process of nuclear fusion, which is the process that these atoms go through inside of a star, is a very intense process and it releases vast, vast amounts of energy. Picture a crowd that is constantly pushing in on each other. The two people at the very center would experience the highest degree of that pressure. Now, imagine in a nuclear fusion situation, those people are suffering so much pressure that instead of squishing together in a massive blood and guts, the pressure is so great that they in fact merge together and become a new living human being. That is the immense pressure and the difficulty of completing nuclear fusion. And that is what happens inside stars every second. Now, after millions of years, when the hydrogen in the stars is completely burned out and converted into helium, the star will enter its next phase in life. Now, that would, if the star has enough mass, it is capable of fusing that helium together to create carbon. Now, a star needs a certain amount of mass, which is unique to each star, to continue that cycle of fusion. However, there is, in fact, no star which can fuse an atom past the element iron, simply because iron would require a ridiculous amount of energy to fuse together. If a star doesn't have enough mass or energy to be able to fuse past a certain element, let's say carbon, for example, it'll enter its death stage. Now, there are three main death stages to stars. The first one is the white dwarf stage, which is what scientists predict our sun will go through. After it reaches a certain point, and it is unable to use the fuel that it has, it'll shuck off its outer layers, becoming what is known as a planetary nebula. It expels all of its outer layers, and it leaves behind its core, which is what is known as a white dwarf. Now, this core will continue to burn and fuse until it simply burns out and it fades into a black dwarf, which scientists predict takes tens of billions of years. Now, since the universe has only been around for about 13 billion years, we actually haven't seen a black dwarf exist yet. But scientists are confident that that is the process which takes place in a white dwarf star. Now, for the next two death stages, those are unique only to larger stars, and those stages are becoming neutron stars or black holes. Now, to become a black hole or a neutron star, the star has to become the very spectacular supernova. Now, what happens in a supernova is that there's too much mass at the center of the star, and there's not enough fuel, and the star collapses on itself under its own gravity, and this creates a very spectacular explosion that is oftentimes brighter than most stars. Now, this supernova explosion leaves behind one of two results. If the star doesn't have enough mass to support itself, the star will continue collapsing on itself. Now, and the gravity of the star will remain, but the mass compacts so much that it becomes a black hole. Now, if the star has enough mass to support itself, it'll continue collapsing until it becomes a neutron star. Now, in a neutron star, because atoms cannot fuse past iron, you will have a lot of iron atoms pressed together so extremely that their own chemistry, the chemistry of the atoms, change. Protons collide with electrons and their charges change and they become neutrons. And the star will become mostly made up of simply neutrons. Not even atoms anymore, just the components of atoms called neutrons. Now, sometimes two neutron stars will collide. And mind you, it is important to note that because of the extreme conditions of the neutron stars, the collision of neutron stars is so spectacular that it creates an even more spectacular explosion called a kilonova, whose energy is strong enough to fuse and create elements beyond iron and create the more heavier elements such as gold and uranium and platinum. Scientists were confused for a while as to how these elements existed in the universe if a star cannot fuse elements past iron. But after observing a kilonova explosion in 2017, that is how they learned how gold and other heavy metals and elements came to be. Most of our environment, including electricity and metal and the ability to communicate via electromagnetic radiation, is all a product of kilonova explosions. These are only a few facts of all of the amazing universe that we live in. I think that it's amazing that this universe is capable of hosting all of these events simultaneously and spontaneously without any sort of conscious control, and it can all still happen in a beautiful harmony. So, next time you send a boy to go to Jupiter to get more stupider, think twice. He might actually learn a lot more about the universe.